Here are your instructions for Lesson 9-5. Lesson 5 is measures of variation. So let's talk first of all about mean absolute deviation. That's going to be a big part of this lesson. You've used measures of center to describe the middle of a set of data, and you have used range to describe the spread or the variation of a set of data. Another way to describe the variation of a set of data is to use its mean absolute deviation. The mean absolute deviation of a set of data is the average distance between each data value and the mean. Or in other words, what we're really trying to find out here is how far is any individual piece of data from the mean of the set of data. So let's take a look at what that looks like. Example number 1. The table shows the heights of the first 8 people standing in line to ride a roller coaster. Find the mean absolute deviation of the set of data. Describe what the mean absolute deviation represents. So the first thing we need to do is find the mean. So we took all of the pieces of data, added them up. There are 8 of them, so we divide by 8 and we find out that our mean is 56. Next, we need to find out how far any individual piece of data is from that mean of 56. So I'm going to write that over here again. This is our mean of 56. Well, our first piece of data was 52. Now, one way we could do it is exactly like they show it in the book here, where we take 52 minus our mean, and then that would be -4 in this case. Take the absolute value of that. That's what these marks here are for, remember. The absolute value of -4 is +4. Another way to look at that that might help an awful lot of you is you're just really asking how far is 52 from 56, let's say on a number line. So that's 4 away. 48 is 8 from 56. 60 is, of course, 4 from 56. 55 is 1 from 56, etc. And we get each of these values here, the distance from the mean. So we have 4, 8, 4, 1, and that's what we have right here for our numbers, 4, 8, 4, 1, and we have 3, 2, 2, 6, 3, 2, 2, 6. So that is how far away each of our 8 pieces of data are from the mean. So what we need to do next is find the average of the absolute values. Remember, these are all the absolute values of the differences between each value in the set of data and the mean. So we take that, add it all up. There are 8 pieces of data, so we divide by 8, and we get 3 and 75/100ths. So we can conclude that the mean absolute deviation is 3 and 75/100ths. This means that the average distance each person's height is from the mean height is 3 3/4 inches. So remember, it's all about find the mean first of all, and then find out how far each individual piece of data is from that mean, and then take all those distances from the mean, add them up, and average them, or in other words, get the mean, and that is the mean absolute deviation. Please press pause and do letter A. Now in mathematics we also have another thing we call standard deviation. You're not going to need to know how to calculate that, but you will need to know how to use it. The standard deviation of a set of data is a calculated value that shows how the data deviates from the mean. In a given set of data, most of the values fall within one standard deviation of the mean. So if the mean of a set of data is 21 and the standard deviation is 3.5, then most of the values fall between 21 minus 3.5. In other words, it would be 3.5 to the left of the mean of 21, or 17.5, and 21 plus 3.5, or 24.5. So in other words, we add 3.5 this way from 21, we get 24.5, and we subtract it this way, we get 17.5. So in other words, we could say that most of the values fall between 17.5 and 24.5. Most of the data, more than half of the data, is going to fall in that spot. So in problem number 2, we're told the standard deviation of quiz scores for class A is about 1 2/10. Describe the quiz scores that are within one standard deviation of the mean. So first of all, we take all those scores, add them up. As you see here, they don't even put them all there because they feel that you have a really good handle on finding the mean. Take the total scores, there are 12 of them, add up the total, divide by 12, and you get 8 and 25/100ths. Now we need to find the range of values that are within one standard deviation of the mean. Well, that standard deviation is 1 2/10 right here. So first of all, we have to go to the left of 8. Let's say this was on a number line and we had 8.25 right here. We have to go to the left 1.2. That would take us to 7 5/100ths. And we also have to go to the right, which is adding the 1.25. That would take us to 9 45/100ths. So we can say that scores that are between 7 5/100ths and 9 45/100ths points are within 1 standard deviation of the mean. Please press pause and do letter B.